Hello, welcome to lecture 4. So today I am going to continue with trigonometry. I am going to discuss some applications and exercises from chapter 8 and 9 of mathematics for class 10. These are based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. Now exercise 8.1, I will go through all the exercises quickly and I will not give all the steps, but requisite steps will be given here and you have to fill in the blanks. You please pause my video and try to do yourself using pen and paper. So now problem number 1. In triangle ABC, right angle at B, AB is 24, BC is 7 and determine what is sin A, cos A, sin C, cos. So this is very easy. So I know that this 24 square plus 7 square root of it is AC is 25. So determine sin A. Sin A is your opposite side, 7 by 25. Cos A is your 24 by 25. So similarly, sin C is your 24 by 25 and cos C is your 7 by 25. So this is very easy. I'm not writing it down. You check in the book. Now problem 2. In figure, find tan P minus cot R. So this one is given, PQ is given, PR is given. So similarly, as I have found here, I can use the Pythagoras theorem and I can find this Q. So once I know this, tan P is nothing but sin P by cos P and cot R will be cos R by sin R. So you substitute this value. So sin P will be your opposite side QR, which you have found from Pythagoras theorem. So QR by PR and similarly you do the rest. These are very trivial, so I'm not going to do it. If sin A is C by 4, calculate cos A and tan A. Okay. So cos A will be square root of 1 minus sin square A. So sin square A, this is given 3 square by 4 square. So square root of 7 by 4. So these are all very easy. So let us go very fast. Okay. Given 15 cot A is equal to 8, find cos A and sec A. So how do you do? Cot A is cos A by sin A is given. Cot A is 8 by 15 because 15 I bring it here. So I know cot is your what? Cot is base by height. So hypotenuse will be 8 square. This is minus 15 square. Okay. So is a mistake here is equal to 70. So this is your hypotenuse. So cos A here is 8 by 17. This 8 is there. 17 is hypotenuse. So both have the same hypotenuse. So it is written 8 by 15. So here I have written 8 by 17. Sin A is 15 by 17. So if you take a cot, you will get 8 by 15. So similarly, sec is 1 by cos. So 1 by cos is, here it is, take a reciprocal of this is 17 by. So find sin A and sec A. We have found what is sin A. Okay, now problem 5. Given sec theta is 13 by 12, calculate all other trigonometric ratios. So I can do this very simple. Sec theta is, I know, is 1 by cos theta. So this is cos theta. That means cos theta is 12 by 13 because this I bring it down, reciprocal of it. So once I know what cos theta is, I can find sin theta because I can substitute here cos theta and I have sin theta as 5 by 30. So once you know cos theta and sin theta, you can find what is tan theta, what is cot theta and other trigonometric issues. I will not do this here. Please kindly do it. Now problem 6. If angle A and angle B are acute angles such that cos A is equal to cos B, then show that angle A is equal to angle B. This we have done in the previous lecture 3, example 2 solved it. Please go through it. Okay, now problem 7. If cot theta is 7 by 8, evaluate this expression and also cot square theta. So how do you find it? I write cot theta is cos theta by sin theta. So cos theta, this is your adjacent side and this is your opposite side. So I can find that this is your hypotenuse will be square root of 7 square plus 8 square, which is 113. So I can write this cos theta as 7 by adjacent side by hypotenuse. This is opposite side by hypotenuse. So cos theta is this and sin theta is this. So I get this value. I substitute here in this expression in sin theta as 8 divided by square root 113 and similarly here 1 minus 8 is 1 plus sin theta 1 minus sin theta. I substitute here and I get this. Finally you just simplify it, you will get something like this, which is equal to 49 by 64. So I want to check one thing, that this cot theta is cos theta by sin theta and you can get this expression here. Okay, I'm trying to see whether this expression comes. So if I square this cot square theta, I get this expression. So if there is a problem that show that cot theta is equal to this, you can do by this simplification or expansion. And similarly cot square theta is this. So this equation and this equation is same. Okay, now let us go to problem 8. If 3 cot A is equal to 4, so that means cot A is 4 by 3. Check whether 1 minus tan square A divided by 1 plus tan square is cos square A minus tan square or not. So this is very simple. Cot A is cos A by sin A is 4 by 3 as I said. So tan A will be 3 by 4. So now I have sin A will be, this is the opposite side, C 3, and hypotenuse will be square root of 3 square plus 4 square. Okay, that is square root of 25, that is 5. So you have hypotenuse 5. So this is 3 by 5 sine, and cos is 4 by 5. So which I have written here. And now I write this 1 minus tan square a. Okay, tan I have found out here is 3 by 4, and I get, if I substitute this tan value here, I get this value, and if I substitute cos square value and sin square value from here, I get this value. So they are both same. So this expression is same. Okay, is equal. So this expression is valid expression. So here I am trying to prove whether this is true. I'm just trying to check. You need not do this part. This is just for us to check it. This is 1 minus tan square a divided by 1 plus tan square a. I can write this as tan is sin square a by cos square a. Cos square a minus sin square a, which I have written here. And cos square a is common, so cos square a will get cancelled. So you will have cos square a minus sin square a divided by, so this is cos square a plus sin square a, which we know it is 1. So this cos square and this cos square will get cancelled. So we are remaining with only this term. So this is okay. This equation is valid. Remark: since hypotenuse is the longest side in a right triangle, a value of sin A or cos A is always less than or equal to 1. So this is, I am just trying to say that, value of sin A and cos A should always be less than 1. Okay, now problem 9. In a triangle ABC, this is a triangle ABC, right angle at B. If tan A is 1 by 3, that means opposite by adjacent, I can always that, because hypotenuse will be 1 square plus 3, square root of that is 2. So hypotenuse is 2. Once I know this, I can find the value of sin A, cos A, sin C, cos C. So what is cos C? Cos C will be 1 by 2. Sin A will be what? Your 1 by 2. So similarly, you find all this, you substitute here, and you will find this is equal to 1 and this is equal to 0. I will not go into detail. These are very simple things. I am telling you the idea. These values are given here. Just check it, freeze it and check. In triangle PQR, right angle at Q, this right angle at Q, PR plus QR, so PR plus QR is 25 centimeters. So that means this will be 25 minus QR, and PQ is 5 centimeter. Determine the value of sin P, cos P, tan P. So this is also very simple. So I can write this is hypotenuse square is 5 square plus QR. So hypotenuse square, this is 25 square minus 2 into 25 times QR, that is minus 50 times QR. And then QR square. This QR square and this QR square will get cancelled. So 5 square will remain. So I have written there 25 square minus 50 QR is 5 square. This implies that QR is equal to, I take it all this side and I get QR is equal to 12. And since QR is equal to 12, then PR will be 25 minus 12, that is 13. So PR is 13. So now I can write sin P is equal to 12 by 13. That is your opposite side QR by 13 is the hypotenuse. And cos P is 5 by 13 and tan P is 12 by 5. So once you get this, you can find other trigonometric relation. Anyway, we have found this sin P, cos P, tan P. So this much is asked, so you should do only this much. Now problem 11, state whether the following are true or false. Justify your answer. Okay, the value of tan A is always less than 1. That is false, because tan A, we have shown that it can become 1 by 0, that is not defined. It's much, it goes to infinity for pi by 2. We have seen this. So see the trigonometric table which we have shown in the last class. Sec A is 12 by 15 for some value of angle A. Yes, this can be possible because sec A can go to very high value and minimum value of sec A is 1. So this is true. Cos A is an abbreviation used for cosecant of angle A. This is false because cosecant is 1 by sin A. And cot A is a product of cot and A. This is false because cot A is one function together. Sin theta is 4 by 3 for some angle. This is also false because it goes beyond 1. So as I said earlier, that cos theta and sin theta oscillates between +1 and -1. So this is also. Okay, now exercise 8.2. Let me go a little quicker, because otherwise it is becoming too lengthy, and these are all too simple and you should do it yourself. Freeze it and please check it. These are, take it as a hint and you should be able to solve this. Evaluate the following: sin 60 degree, cos 30, this one. So I take the values from here, substitute here, and I find it equal to 1. I will go a little faster now. 2 tan square 45. So tan 45 value you take it, tan 45 is at 1. So here I have written 2 into 1. Okay, you substitute this value, you get 2. These are very simple things. Once you have the table, and I have shown you in the last class how to use, you can draw it on your fingertips and you can find these values. Now cos of 45, this also is very simple. see this cos of 45. What is 45? You see is 1 by root 2. Sec of 30 is 2 by root 3, which I have here written. Cosec of 30 is 2, I have written here. So I have to simplify this denominator. So I multiply and divide by the conjugate one. That is, the plus becomes minus 1. Numerator and denominator, I take the conjugate of this. And I will, if I do cross multiply this and if I simplify, I will get this, and from here I can write this. This is 4 minus 12 is minus 8, and I just flip it to get rid of minus sign. So this is the answer. Similarly, this also you should able to do it quite lengthy. I don't want to waste time. So here this value is half, tan 40 is 1, cosec is minus 2 by root 3. So similarly you do it here and you simplify it and just freeze and see it, and you will get this answer. Check in your book also, behind the book, whether this answer is correct. Okay. Now problem 2, I have taken only one of them maybe. This is 2 tan 30 minus, because these are all very similar. So once I put this value, I get square root 3, that is equal to tan 60. Maybe it has asked this is equal to tan 60. So yes, it is equal to tan 60 degree. So you know this a by b divided by c by d is nothing but a by b into d by c. This you have studied in very preliminary, maybe in primary school. So this I am not going to, this you all should know in 10th standard. Now problem 3, if tan a plus b is equal to root 3 and tan a minus b is 1 by root 3. So a plus b is root 3 for tan, that means this is 60 degree. So a plus b is 60 degree and a minus b is 1 by root 3. So tan of 1 by root 3 is, that means a minus b is 30 degree. And if I write a plus b is equal to 60 and a minus b equal to 30, I can, it is been asked to find a and b, provided this a plus b is less than 90, because we are only considering this chart. So a plus b is equal to 60 degree and a minus b is 30 degree. I just subtract this b, 2a is equal to 90 degree. So I get a is equal to 45. So similarly, if I know that a is 45, so 45 minus what will give you 30, that is minus 15. So b is 15. So 45 plus 15 is 60. This you have studied in your 9th standard, more difficult problem than this. Okay. Now exercise 8.3, this is the identities we are going to use, okay, which we have derived in the last lecture. So problem number 1 of exercise 8.3 is that evaluate this quantity sine of 18 degree by cos of 72 degree. We'll use only these identities, and these are the things which you have to do. For the first one, this is your cos of 72 degrees, what cos of 90 minus 18 is 72. So I write cos of 90 minus 18, that is sine A. So it becomes sine 18. So similarly here also, cos of 26 and cot of 64 is cot of 90 minus 26. Okay. And so cot of 90 minus 26 is tan A. So I have written tan A. So this cancels. So is 1. So similarly you do cos of 48 by sine of 42. You should use this identity substitute. Sine of 42 degree will be sine of 90 minus 48. Okay. So sine of 90 minus 48 will be cos of 48. So this 48 cancels. So similarly you do this also. Now problem 2, show that this quantity, this tan of 48 into tan of 28 degree, tan of 42 degree into tan of 67 degree, this all multiplied is equal to 1. So again I use these identities. I keep this as it is. You should see here it is 42. So that means I will use, and here is 48. And I know that tan A into cot A, because this is sine A by cos A by sine A. Both of them will cancel and become 1. So I should see first which one I should convert. So I know that I have to make this cot 48, because tan A and cot A, tan A into cot A is equal to 1. So this I make it cot 48 and this one I make it cot 20. So this can be done using this identity. So once you have it, this and this will become 1 and this and this. So 1 into 1 is 1. Now similarly here cos 38, cos 52. So 52 is nothing but cos of 90 minus 38. So you do it. So again you will get here same, it is equal to 0. So it is okay. Now problem 3, if tan of 2a is equal to cot of a minus 8, where 2a is an acute angle, find the value of a. So here what do I do? Tan 2a I can write as cot of 90 degree minus 2a. Okay, for using this identity. Now I equate this, 90 minus 2a is equal to a minus 18. So I rearrange and I will find it a equal to 36. This is 108 divided by 3 is 36. 4. If tan A is equal to cot B, then prove that A plus B is equal to 90 degrees. So I will prove here other way around, that if A plus B is 90 degrees, then this is true. This also you can do from converse. So here I know that A is equal to 90 minus B. Okay, B comes here. Then tan of 90 minus B is what? Is cot B. But 90 minus B is A. So tan A is equal to cot B. So from this condition, I can come here, or if so, this is now 5. If sec 4a is equal to cosec a minus 20, where 4a is an acute angle, find the value of a. Okay, so here again I do sec 4a is equal to cosec of 90 degree minus 4a. I take it from here. Okay, sec and cosec, this identity, and so that means 90 minus 4a is equal to a minus 20. This here, and I again equate it and then find a equal to 22. These are very simple ones, but anyway, let us do it. Problem 6. If a, b and c are interior angle of a triangle, then show that sine of b plus c by 2 is equal to cos of a by 2. So what do? I know sum of internal angle is 180 degree. So b plus c is 180 degree minus a. So b plus c by 2 is 90 minus a by 2. Taking sine of both the side implies, this should be implies, okay. Sine of b plus c by 2 is equal to sine of 90 minus a by 2. So this is sine of 90 minus a by 2 will be cos of a by 2. So we have proved here. This is problem number 7. Express sine 67 degree plus cos in terms of trigonometric ratio between 0 degree and 45 degree. So sine 67 plus cos 75 I can write like this. Again, I do use the other identities. 67 is 90 degree minus 23. So this will become cos of 23. And similarly, cos of 75 is 90 minus 15. So this will become sine of 15. So these angles are between 0 and 45. 23 is between this and 15 degrees between. Now exercise 8.4. Problem number 1. Express trigonometric ratio sin a sec a tan a in terms of cot a. I will use this identity, and sin a I have written here. You just go through it. Here I have written what is sec a in terms of, everything is in terms of cot a. Okay. So I will not go into detail. Tan a is 1 by cot a. So write all the trigonometric ratio of angle a in terms of sec a. See, this is a very similar question. So sin a in terms of sec a. So this is in terms of sec a. Then cos a in terms of sec a. Okay. Inverse of cos is sec, or inverse of sec is cos. Okay. Tan a again I have written like this. And cot a also you can do from here tan. Now it is cot a is 1 by tan a, or I can write tan square a. And tan square a is sec square a minus 1. And cosec is sec a by tan a. So sec a it is there already. Tan a is square root of 1 plus. So you use these identities and show it. It is very simple. Now problem 3. Evaluate these things. And second problem is evaluate this sine of 25 degree into cos. I will not read all this problem. You just see it. And here you see sine of 63 I have written as cos of 27. And cos of 73 as sine as 17. So with this you just substitute here and find out whether they are equal to 1. Okay, problem 4. 9 sec square a minus 9 tan square a. So I can write this as 9 I can take common, and sec square I can take 1 by cos square, and this is 1 minus sine square a, because sine square a by cos square a, this cos square is tan square a. So this 1 minus sine square a is cos square, so this cos square and this cos square a will get cancelled, equal to 9. You just go through it. I have written straight. I have not used the mathematical font, but just go through this. Similarly, for this expression I can write this is tan theta, I expand it, sine theta by cos theta. Then this is 1 by cos theta, so cos theta I take common. So I expand both. Okay, just go through this and you will get this is equal to 2. Okay, this sine square theta plus cos square theta is 1. So this sine theta, cos theta and this sine will get cancelled, so it will remain only 2. So you should go through all this, and sec a plus tan a into 1 minus sine a is equal to 1. So that we can always show. You just match with your textbook what they have asked, and those who are not following the textbook is not so important. You can see from here what I have done. It will be self-explanatory. So 4 problem is 1 plus tan square plus this. Again I do here. Tan square is sine square a by cos square a. So cos square a comes here. Cos square a plus sine square a becomes 1. And in the denominator you have cos square a. Similarly here you have sine square a. So this equation is nothing but tan square a. Problem 5. Prove the following identities where the angles involved are acute angle for which the expressions are defined. So these are the problems given that we have to prove that this is equal to this. So I didn't wanted to waste much time in writing so much in my PowerPoint presentation. So for this problem, let us try substitution method, that is sin a is equal to x. I just simply write x, and then once I solve this, I can again put back x is equal to sin a, and cos a is equal to y, again put back y is equal to cos a. But here sin square a plus cos square a is equal to 1. So x square plus y square is equal to 1. This condition is known. I will recommend students not to use my way here x and y. Here I am just doing it to make it short, and for me it is less troublesome to write all the time sin A, cos A. So I can simply write x and y. But sometimes you may make mistake if you do this way. You better, wherever I have written x, you should write sin A. And wherever I have written y, you write cos A. Okay, so let us do this substitution I have said. So cosec is 1 by x, that is 1 by sin x, minus cot is cos of A by sin of A. Here I have square. So I do the square, I do some little algebra here. I will get 1 minus y divided by 1 plus y. Now I substitute this y is equal to cos A because I have said, and this is equal to cos A. So this is, I get this here. This is, for me it is easy, but you all should not, maybe in exam you cannot do this. It is okay for you for practicing. And here again I will, this identity you have to show. So again I will use the substitution method. This cos A, okay, this is cos square A, this I cross multiply, and 1 plus sin A, again I cross multiply here. So 1 plus x, you see 1 plus x is sin A, this is cos A is y, so y square plus this, and then this is y into 1 plus x. So I just again simplify this and I will get here 2 by y, and y is your cos A. So 1 by cos A is sec A, so it is 2 sec. So go through it, freeze and go through it. It's very simple. All the steps have been given here. So similarly for this identity also I will use this x and y, that is tan A is sin x, sin A by cos A, where sin A is x, cos A is y. So again 1 minus y by x, that is cos of A by sin of A. And now you substitute here also same thing, and you just, again as I said, you just freeze it and see how I have done here, and you will get here x square plus y square plus xy. So this is, now I write here x square plus y square is 1, I know, x is sin A, y is cos A, and this is sin A. So you get this one. So here 1 by sin A by cos A is 1 by sin A is cos A is sec A. So this you get from the first term, and sin, this term and this term get cancelled, so you get 1. So I have done it in a shortcut to avoid writing too much and make it lengthy. This is neat way if you are confident. Now prove that is equal to, this expression is equal to this expression, and use this identity. So here to avoid this mistake, because this identity is involved, so now I do the conventional way. So now this I simplify, I use this condition here. So I write here cot A minus cosec A, I put it here minus 1. This condition I am going to use. So minus 1, if I bring it here, it will be cot square A minus cosec square, which I have written. That is A square minus B square. So A plus B into A minus B I have written here. And now I simplify here. I know this is a common term. So it is 1 minus this times this. Now this quantity and this quantity is same, so I cancel out, and so I get this is equal to cot A plus cosec A. Okay, now problem 6. Square root of 1 plus sin A divided by 1 minus sin A is, we have to prove it is sec A plus tan A. So again what I do is I write this and I substitute sin A is equal to x and cos A is equal to y. So I multiply and divide by the conjugate. This is minus 1 minus x. So I multiply and divide by 1 plus x inside the square root bracket. So I get here 1 plus x square and 1 minus x square. This is 1 minus x into 1 plus x. Okay, a minus b into a plus b is a square minus b square. So this 1 minus x square is nothing but y square in earlier condition which we know. And this is 1 power 1 plus x the whole square. Square root of this will be, give me 1 plus x, and square root of y square will give me y. So now I can write 1 by y is sec A, 1 by cos, and x by y is tan A. So I can get it. Now prove that this identity is equal to this one, tan A. So again I do the same thing, x minus 2x cube. Okay, this cos q A is y cube minus y. Again I take common x and I do some little algebra and I'll get x by y, and this is equal to sin A by cos A. So this is tan A. Okay, now problem 8. Show that this expression is equal to this expression. So now I will do the substitution method, but with this condition always keeping in mind x square plus y square is equal to 1. As I have said that sin square theta plus cos square theta is always equal to 1. So this is valid. So now again I use this substitution method to make it short. So this is your x and this is your 1 by x. So if I take a square, I expand it, x square plus 2x times 1 by x. So x get cancels, only 2 remains, and 1 by x square. So similarly I do for this also. And once I simplify this, freeze and see it, I will get something like 5 plus 1. Okay, this 5. Then this x square is there. This is get cancelled with here. So go through this simplification. You will get this as 7. 5 plus 1 6 plus 1 7, 7 plus this is your cos by sine square, that is cot square, and then your sine by this y is cos, so sine square by cos square is nothing but tan square. So now 9 cosec a minus sine a, this is the expression given that show that this expression is equal to this. Again, sometime I will use substitution, but if I'm not confident I will use this. So cosec a minus sine a is nothing but I can write at 1, this is 1 by sine, so it is 1 minus sine square a, and denominator is sine a. Just simplify this. So this you get sine a into cos a, this is a left hand side, and I take this right hand side and again I simplify this and I get sine a into cos a. So there is another way of doing that. If A is equal to B and B equal to C, then A equal to C. So this is how I have put that this is equal to left sine A cos A, and this term is also equal to sine A cos A. So that means this has to be equal to this. Okay, this is left hand side, this is right hand side. Now point 10, this expression is equal to this, equal to tan square A. Okay, so I can show that first this is equal to tan square A and this is also equal to tan square. So how I do it? I expand this sine square A by cos square A, then this cos square A which is below, cos square will come here, cos square a plus sin square is 1. So this will become 1 by cos square a, where I have written it. So similarly you expand this and then you get tan square a. Similarly right hand side also you should do it, you will get tan square a. So here left hand side equal to right hand side, and that both are equal to tan square a. Now some more definition in this geometry, okay, some insight to this. So if a person stands here and looks at something, so this is called the line of sight, and this is your horizontal line. So angle between this line of sight and this horizontal angle is called elevation because it's going up, and from this horizontal line and this line of sight is called the angle of depression. So when we do some word problem, these definitions will be used. So first, the line of sight is a line drawn from eye of an observer to a point in the object viewed by the observer. So this is a line of sight. And second is the angle of elevation is an object viewed in an angle, okay, formed by the line of sight with the horizontal when it is above the horizontal level. Okay, so this is the horizontal, this is above the horizontal, this level. Okay, the case when we raise our head to look at the object. So when you look up, okay, that is the elevation, angle of elevation. And angle of depression is when you look down, okay, from this, when you are looking down on the line of sight from this horizontal line, this is the angle of depression. The height or length of an object or distance between two distant objects can be determined with the help of trigonometry. So all this height or length you can use a trigonometric relation, that opposite or side or adjacent side, or how much is this distance from the hypotenuse. Okay, from the trigonometric ratio you can. Now let us do exercise 9.1. Problem 1. A circus artist is climbing 20 meter. Okay, this is a 20 meter long rope which is tightly stretched and tied from top of a vertical pole, this is a pole, to the ground here. Find the height of the pole. So you have to find AB. If the angle made by the rope with the ground level is 30 degree. Okay, so we have been asked to find the height of the pole. So I can find opposite side is sine, I have to use sine function. So sine of 30 degrees AB by 20 meter. Okay, so AB is sine 30 into 20 meter, that is 10 meter. So this length is, height is 10 meter. So the height or length of an object or distance between two distant objects can be determined with the help of trigonometric ratio. So this table, you just fit you just put this value of sine 30, you will get sine 30 degree is half, so half into 20 is 10. Okay, now problem 11. A TV tower stands vertically on a bank of a canal from a point on the other bank directly opposite to the tower. The angle of elevation of top of the tower is 60 degree. Okay, from this point is 60 degree. From another point 20 meter away from this point, 20 meter away from this point, on a line joining this point along this line only from the foot of the tower, the angle of elevation of the top of the tower, from here now the elevation is say 30 degree. Find the height of the tower and the width of the canal. Okay, so we have been told to find the opposite side of this angle of this 60 degree or 30 degree and the adjacent side of this small triangle. Two quantities we have to find, and given two quantities is angle 30 and angle 60. So how do I do? Tan of 60 is opposite by AB by CB, I have written here, and then tan of 30 is AB by DB, which I have written here, that is DB is 20 meters plus CB. Okay, so I put this value from my trigonometric chart. So I get AB is equal to, this may be root 3. So root 3 times BC, and this is tan of 30 degrees 1 by root 3. So then AB is root of 3 times BC, which we have found here. So you get this expression, okay, 20 meter plus BC is equal to 3 BC. So you get BC is equal to, then is 10 meter. So now since BC is 10 meter, that means dB will be 20 plus 10, that is 30 meter. So again I can write tan of 30 is opposite side AB by DC. DC is 30 meter. So AB is 30 meter into tan 30. Okay, because tan 30 degrees opposite side upon 30 meter. So AB is equal to 30 meter into tan 30 is 1 by root. And 30 meters I can write as 3 into 10. So this is 10, and 3 divided by root 3 is root 3. So this is 10 root 3 meter. Okay, now 14. A 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 from the ground. From this point to the ground is 88.2, and the girl's height is 1.2 meters. So it will be from the eyes, from this eye side, it will be 87 meters. So that you have to consider, because this is the line of sight and it begins from here, the eye is here. So you have to subtract this 1.2 meter from this 88.2, you get 87. So what is saying, the angle of elevation of the balloon from the eye of the girl at any instant, initially the balloon is moving there. So initially it is 60 degree. After some time the angle of elevation reduces to 30 degree because it's going far away. So this is the elevation. Find the distance traveled by the balloon during the interval. So in that time, what is the distance between here and here? Okay, that is distance BC. So here we write, for the initial thing, this is 60 degree. I write tan 60 is 87. This is the opposite side. This height is same, 87 by AB. This is, and tan 30 will be your opposite, same 87 by AC. So here AB is 87 by, so AB is nothing but 87 by tan 60 is root 3, and tan 30 again I write as 87 opposite by adjacent. So adjacent is nothing but this AB plus BC, 87 by root 3 plus BC. So this again I write it here, 87 by root 3 I bring it here. This is the BC here, and tan 30 is 1 by root 3. So you get this is equal to 87 here. So now you can find what BC is. So you keep this BC in the left hand side, take rest of them this side. You do this algebra and you get BC is equal to 58 times root 3 meter. So find the distance traveled by the balloon during the interval. So this is the distance traveled in that interval. First the balloon was here, then it moves here, angle is given, and this distance BC we have. Okay, thank you, and we have finished the trigonometric section of your class 10th maths book.